I like Formula One, and recently, before a race weekend, I saw Vercel release their generative AI SDK. I want to talk about how I take my interests and I utilize them to learn something new. Not releasing a product or anything, just building something fun for myself in that pursuit of learning. We're going to be building a AI chatbot that has access to PDF documents, web, and also real-time F1 information. As I said, it's not fully finished yet, but what I want to show you is my process for how I jump into these things and learn them, as well as all of my failures along the way, as there were many of them, on how we build something like this, and hopefully you can learn from them as well. So let's take a look at how we can build this using Vercel's generative AI SDK, as well as some other tools like Pinecone, OpenAI assistants, and more. Let's jump into it. To show off those features, here I am in my F1 GPT demo here. Haven't published this anywhere. This is actually my local host version, as I haven't got the code ready yet to publish it live, but you'll see later on some versions that you can actually go and check out. If I ask it, why did Lewis get a penalty in the Miami sprint? I'm expecting this to go off and search my PDF documents, so the official FIA documents, for why he got that penalty there. And you'll see it summarizes really nicely that he was speeding in the pit lane, so got that 20-second penalty. And then it even shows us the official FIA documents here. So we can actually click on that and go to the FIA website, showing us that infringement report. The next feature we can show off is that web search piece. So if I ask it where is Hulkenberg going in 2025, this is really good to go and get the latest news about Formula One, as it's going to go and search the web for that. And I've actually curated the list of websites that I've given the API to search for. So you can see here it says Nico Hulkenberg will be moving to Sauber, and then it even gives us the articles it found that in. And I've also added a reliability score, which actually comes from the Formula One subreddit, and that's essentially just how trustworthy the news source is. And you can see obviously Formula1.com is going to be quite trustworthy. The other piece that we have as well is that real-time race information. So if I ask it, what did Norris just say? It's actually going to get from the F1 API that real-time race information for the latest team radio that he mentioned. And we can also ask it to provide a transcript or play the actual audio here. And you see we have Norris here thanking his mum, dad, and grandma for his first win in Miami the other day, which was really awesome to see. And on that same way, we can ask it what is the current track weather, and it will return that for us like that. So that's essentially those features that I mentioned that we're going to be adding and what I've learned to build here. So let's take a look at how I approached all of this. The idea came about when I saw Vercel's tweet about the release of their AI SDK. In this blog post, the highlight was their generative UI, allowing you to stream components to a front end. For example, if you ask for the weather, instead of getting a boring text response, you could get a nice visual weather component. I did a separate video on this when it came out, covering the basics with their stock chatbot demo. I wanted to delve deeper into this and integrate my own components into a chatbot to learn how it works and the advantages and pitfalls of this method. But I wanted some new ideas to integrate. That's when I saw another tweet, conveniently on a race weekend, from the CEO of Vercel himself, showcasing a website called F1 Dash that offered real-time race information in a Next.js Tailwind front end and Bun TypeScript backend, all open source. This offered me the backend connection and examples of components I could use. So the idea for me was to essentially merge the two projects and turn F1 Dash into a chatbot. This is why I love open source. As a self-taught developer, open source has been the key to my learning, as I find I learn by doing. So being able to see real working examples allow me to dissect lots of different projects, putting 1,000 console logs in, or being fancy and using breakpoints, and see how it all fits together under the hood. The other part that you may notice in this video is the importance to me of a community. I learned about these projects through Twitter, or X I guess, and I find it a great place to see what people are up to and working on, and what the trending topic is in the world of web development or the big debate. All you have to do is curate your feed a bit by following people you're interested in, like me, or the people at Vercel, Theo, Josh Try Coding, WebDev Cody, and hundreds more. Now this here is what I had after a couple hours of hacking. As you can see, it really is just a mashup of F1 Dash and that stock demo that they had. We can ask it the same thing I showed you in the demo earlier, which is my second iteration, and this is my first one, and you can see it's just the F1 Dash components here with those same pieces of providing the transcription and stuff. So I've pretty much just merged it into a chatbot UI here. We can even ask it other cool stuff like who is the best YouTuber, and it will return really good answers such as Jolly Coding, someone you should definitely subscribe to. Let's check out the code for this. Most of the magic happens in this action.tsx here. When the user presses enter on the submit form, it calls this submit user message with the text content of the input. What you'll see here is we create a reply. So we have const reply and we create a streamable UI. As I just said, we're going to stream this to the client now. And on the client side, it's literally just reading a normal React node message. So the first thing we do is we return a bot message, which is just going to have like the icon for the bot, and then also a spinner. So that's just going to return the spinner to indicate that it's loading. Next, what we do is we set up the call to OpenAI. I'm not going to show the code for our OpenAI completion, as it's actually been massively simplified in the next version of the AI SDK, which I use. So I want to show you sort of the differences there. But essentially what we do here now is we go through it. We set up our model. I'm using GPT 3.5 turbos. It's a lot cheaper than GPT-4. I didn't do any fancy prompt engineering here. I just tell it what function I expect it to run, and then it can infer it itself. So you've got these bits here where it says, if you want the latest team radio, call latest_radio. And then also we get the access to the chat history here as it runs over the AI state and then gets the messages and maps it. So this is how we can send sort of the context to the OpenAI LLM. And then that way it has sort of the history of the messages, so it knows to use them in some of its answers as well. Now, functions is where the magic of this happens, and functions have actually been renamed to tools in the next version of the AI SDK, which I'll show a bit later. But essentially what we do here is we give it a name and a description. It can use this description to infer whether to use it or not. Then we also give it a XOD schema. This defines the parameters that it should call your function with. So here it allows it to infer from the chat context as well. So if we asked it to call latest radio, what it will do is it will go off and say, should I call latest radio? As I said in the prompt earlier, we actually told it explicitly to, but it could infer it itself. And then in the parameters as well, we have the F1 driver's full names, infer this from the chat. So the actual LLM is going to go and fill in the parameters for you. So if I go to the latest radio, what you'll see is we're passing through that driver. So the LLM or the chat, whichever model you're using, is going to infer that. So it's going to pass through the driver name. And what we simply have to do is then we can run whatever we want inside of here. So we could run our API call. So you'll see in the transcribe audio, I actually call off to a separate API, which is the OpenAI one, to transcribe speech to text. And then I get some JSON back as a response, and I can stream that back to the user as well once we have that. So with that bot message, I can just update the reply with reply.done, as that's going to be the final message, and then that bot message. And then for the other components, such as the ones that have real-time information, all I do is really simply just return a client component, and then the client component itself can handle streaming in that data using the WebSocket. As I said, this was really just a quick hack together. In the future, and the best for learning, you could then use this project and rewrite it from scratch with Next.js to really get a feel for how all of the pieces come together. Now that I have my example project, another part I want to quickly talk about is the hosting. This isn't a sponsored section, to be clear. I just want to talk about two platforms that I love for my personal free projects. The first is obviously Vercel. The second, for my F1 backend Docker container, was Fly.io. My reason for liking Vercel is obvious, just how easy it is to host a Next.js project on there. You literally just need a Git repo. And Fly.io is really similar in that it's super easy to push up a container. Even more so, they both offer really generous free plans and don't even allow you to go beyond that by accident, something I find pretty important as I don't want a scary bill one day. Now, a next step is sharing it with anyone. As I said, I like Twitter for this, so I shared the demo with my feed. The tweet actually caught the attention of the guys at Vercel, with the CEO retweeting it and Lee Robinson including it in a video, among others, of great examples of the AI SDK. He even reached out to me in my DMs and sent me some Vercel swag too, which is really cool of them. So there we go, my first look into the AI SDK was complete, and I had a demo of streaming components back to the front end with the extra bonus of using a speech-to-text API. I left this project in a nice state, and I left it there for a bit until the next AI SDK release came out, and I wanted to include some additional features and try some of the new updates. Version 1 of F1 GPT only had the generative streaming bit. AI SDK 3.1 offered to make this much simpler from a code point of view, really simplifying the way function calls can be handled. In the meantime as well, I saw a really good example on Twitter from Yoshiki that's essentially an open source perplexity. It allows you to search the web and have multiple sources summarized for you by AI to give you a nice answer to your question. For example, if I asked it, where is Lewis going in 2025, it will return results about his move to Ferrari and how he'll win his 8th championship next year. So this would be cool to add to my bot, I thought, as it can bring that real-time information in like this into the context of the AI chatbot. Finally, I also wanted to learn about PDF document retrieval, as a lot of people like this feature. I knew of two options to achieve this, OpenAI Assistant and Pinecone vector databases, later finding out these differ in complexity quite a bit. Let's take a look at how the code came together. The first thing I want to point out is just how quickly I managed to test the file search piece with OpenAI assistants. All you have to do in here is set up and create an assistant, and then you can upload your documents to the storage here using literally the web UI. And then in your assistants, you can even go to the playground and play around with it. So we could ask it again, why did Lewis get a penalty in Miami? And then we hit run here, and you'll see it will really quickly return the results of that. It will run that retrieval step for us, and then it will give us the response we wanted and even show you the citation here. My issue with the OpenAI assistant was that I wanted the results to come back as JSON and in context, and I didn't want the actual OpenAI assistant summarizing it for me. I wanted to run that off into my own LLM, so maybe I could switch this out for Anthropic or something to summarize that different content that it would return from my database or from my files. This is when I decided to try out Pinecone. Learning a lot later that Pinecone massively differs in its complexity. But what we have here in the Pinecone database is we have our vectors that we've uploaded. So this value here has come from the embedding, which I've actually called off to an OpenAI model to do these embeddings. And then I also attached the metadata, which is just going to have the text of the PDF or that chunk specifically, the URL, and the file name. So this is the Pinecone web UI. As I said, there's nowhere in here that you can upload your own PDFs or anything. You have to do that all yourself after you've embedded it. You literally just upload your vectors to this using an API and the various SDKs that they have. Now to the code. So this is where things have been massively simplified in terms of that AI SDK, as I mentioned, especially when it comes to calling functions, which have now been renamed to tools. What we can see down here is we're using the stream text function from the AI SDK. This comes from Vercel's AI SDK. And they actually have different ones such as Stream UI as well, which is where you can just stream back a React node itself. You can find all of this in that documentation that I'll link down below. So after we've defined all of our model settings here and we've got that system prompt, what we then have is this tools object. In this tools object here, what we have is we have latest radio. And then this essentially in the tools object, all of these keys are now the name of the tool we want to call. We have that description as before, which is the description provided to the LLM. We have the parameters again, which is the parameters the LLM is going to infer to give. So we have that F1 driver name before. But now the bit that's been a bit simplified is that like tool function.on function call bit. All we have to do now is pass an execute key to our latest radio object in the tools here. And then we can actually define that in here as a function itself, which is going to run when that's called. So for example, if we're running that latest radio call, then I simply just update the UI stream with null first to get rid of the spinner message, and then I append the bot card with the team radio message component. The other bits that we now need to focus on are the searching. So how do we go off to the Pinecone database? So as I said, here we have the user query. So the FIA search tool is the one that's going to handle going off to Pinecone. What we have here is in the parameters, I have the query. So the LLM is going to infer what we're trying to search for and sort of summarize it a bit more. This query then gets sent off to getContext, which is a function I've made myself to do with the Pinecone. So if we go into the getContext function, what you'll see is we pass it the message that we want to search for. We also have some other things like namespace, max characters, but the main one is this message. Then we actually need to embed it ourselves. And this is where things get way more complicated than OpenAI assistants, which you'd literally just send a string to the assistant call and it would handle all of this for you. But what we have to do is we first have to embed the message ourselves. So embedding that, we then call off to OpenAI to embed the query. Once we have the embedding, we can then call get matches from embedding. Essentially, what it does is it compares the string we gave it with all of the strings as in the vector database and returns the best matches. And it returns that as sort of an object of the content that was in it, the URL, and different things like that. And even has a score for how accurate it is if you want to sort of filter by higher accuracy, for example. Yes, that's a lot of information, but there we go. Essentially, all it does is then return that object and put it in the AI state. Now, let's look at that search piece. So searching for web information. This one is a lot simpler with a really nice API. I'm using Tavily API, which is the one that I saw Morphic use, as I mentioned earlier. Tavily is essentially a search engine built specifically for AI agents. It doesn't have a JavaScript SDK at the moment, but it does have a REST API. All we have to do is we take our user query. So here you see again, we have that search. So if it's going to run this function, it's going to have that user query to search for. Then it's also going to have max results. Now this is maybe if the user asks, can you give me some more results? You can essentially allow the bot to infer that it should give some more. And it also has search depth. The first time you ask for something, it might automatically default it to basic. But let's say if you asked for more information or the user asked for more information, it might then run an advanced search, which is essentially just going to return a bit more content per website. So once that's done here, essentially all we have to do is call the utilise search here. The utilise search function just runs off and makes a fetch request to the API. So if we now go back to our action, what you'll see is we just get the result of that, and similar to the FIA search, we just return that into our AI state. And as I said, the while loop now will run over again and run through that. Now, the last piece is how we attach sort of the sources, so we can actually, the user can click on the links that the AI has looked at to get all of this content. So once everything is complete and the stream text is done, I then say which tools have we run. If we've run the FIA search tool, I then just update the UI stream to append to the FIA section with the result of that tool. So we can actually get the result of the tool, which again is just going to be that JSON with what documents have I looked at, the context, the URL and stuff. And then I can handle this on the front end side simply with React and Tailwind, just to update the user on the information as you saw. And the same thing goes for that search component there. We do the same there. So that's pretty much all of that code. And as I said, that tool stuff has been massively simplified in this new AI SDK. I absolutely love this method of doing it compared to before, as it felt a bit disjointed with the separated sort of functions that we have. I understand that may have been an absolute lot to follow, and this is more an overview of my steps and just how you could actually approach learning this. If you want me to go and create a full tutorial, do let me know in the comments below. I also have the Morphic project linked below, and as said, that's a really good example of this. The Vercel team even go and help out with some pull requests over there as well, so make sure you check that out. There we go. I now had the demo I showed you at the start of the video and have achieved my learning goals with it so far. Learning to use generative UI, integrating the web and documents into a chatbot, and using that live information again. But it's not over. I want to discuss a few things I failed at along the way and what I have learned from them. My first big mistake didn't really involve the code at all that I showed you. I'm not sure what I would label it, but it was essentially scope creep and getting too caught up in the idea of perfect. For the live F1 information, I wanted more from the API. I'd made changes to the Bun TypeScript backend to suit my needs, but for some reason, I really wanted to use this new API I found called Purple Sector that was written in Rust and didn't have the WebSocket component in it yet, but it had more access to historic F1 data. F1 Dash also had a version 2 beta where that backend is now written in Rust. But what's the problem here? Well, the issue is I don't know Rust yet. I might know enough to hack about in an existing project, but I wasted time trying to modify them when I didn't even learn the Rust basics yet. I got too caught up in the idea that the Rust is best rhetoric, believing my demo app with one user for some reason had to be perfect and scalable. It doesn't. Build in what you know and what you can move fast in when the area you're trying to learn isn't a new language itself. So that's why I labeled that as scope creep as well, as I wasted time turning this project into a Learn Rust demo. I might be able to revisit this for that purpose one day, but for the AI chatbot side, it didn't need it yet. My next failure is a more positive one in my opinion, and was to do with the Pinecone document retrieval. As I showed in the code demo, my first iteration had me upload some simple PDFs to OpenAI, and they handled the rest for me. With Pinecone, I needed to do the embedding, the chunking, and the choices around the models and dimensions as well. I found the results to be worse than the OpenAI assistant. For example, if I asked it what is Article 55.13 of the sporting regulations, OpenAI returns correctly, all cars that have been lapped by the leader will be required to pass the cars on the lead lap and the safety car, whereas my Pinecone implementation returns the wrong information, similar to Michael Massey. This isn't an error with Pinecone, to be clear, it's my skills in implementing it. But again, I had to limit the scope to learn what I originally intended, and learning the deep weeds of AI embedding and vectors was not the goal of this project. Funnily enough, I've actually seen others express this. Brodsky, who's building Fay.com, an app that has access to the SEC filing PDFs, tweeted that they made their AI more reliable by moving away from Pinecone to the OpenAI assistants, with the added benefit of simplifying a lot of their code. I'll leave a link to that tweet below as they mention other improvements you can do too. Hopefully that has been a good recap of my learning process and showed you how I approach these types of projects. Step 1 for me is looking what's out there already and then hacking together from there. The other important part being that community to find and share cool projects so you pick up on cool examples here and there. Not everything you make has to be perfect. The code I had is an absolute mess, but I feel I have achieved what I wanted to, gaining a little more knowledge in how to integrate some of these advanced features into an AI chatbot. It's important not to be scared of failure or subpar code, as this was just learning. Not everything has to be a money generating side project. You're going to make loads of simple demos to side projects that won't get any traction, and that is okay. Just take your interests, combine them, and learn something new. Embrace your curiosity. If you're ready, feel free to open source them, as one day someone might be learning from what you've created. Even if you think it's the most simple thing in the world, I promise you someone will find it one day and learn from it. That's it. If you want an in-depth tutorial into some of the code I showed, let me know in the comments down below, and subscribe so you don't miss them. Thank you very much for watching.